Hello, everyone. Welcome to another RxM Cloud Native Short Take. I'm Christian Lacsina, and today I'll be short taking the concept of namespaces in Kubernetes. We'll be covering the concepts and implications of Kubernetes namespace in this short take. So what are Kubernetes namespaces? Kubernetes namespaces are logical partitions of the Kubernetes API. And what this does is it allows multiple consumers of a single Kubernetes cluster to deploy resources while minimizing conflicts between each other. Think of maybe having multiple teams using the same cluster. And so it's really up to the consumers of a Kubernetes cluster to decide how they should actually partition that cluster, whether they do so on a per user or per team basis, on a per application basis, or maybe per group of applications, such as grouping all your observability tools or service mesh tools all in the same Kubernetes namespace. Namespaces are an integral part of the resource identification in Kubernetes. So everything in Kubernetes must have a unique metadata.name field. This name is part of the object's uniform resource identifier, or URI, in a Kubernetes cluster. And these URIs must be unique within a given cluster. And so the URI is going to reflect parts of the name and in some cases the namespace. But also remember that some objects are cluster scoped and thus not namespaced. So we can see here for a node, for example, its URI is simply going to state API/v1/nodes/my node name. And that's fine because nodes are most likely going to be uniquely identified in the network thanks to their host names. However, in some other cases, there will be a series of objects that are namespaced. Think of things such as deployments, for example. For these objects, the namespace is part of their URI, and thus the namespace serves as another unique identifier for that particular object. So for example, a deployment here will have the URI of API/apps/v1/namespaces/my namespace/my deployment. So we see here that the namespace is an integral part of that object's URI, and thus, regardless of how many other people create deployments called my deployment, they will still be unique inside the Kubernetes cluster. Now, how can you see these URIs? Well, you can always use the ---- verbose or -v followed by a number, and that's going to show your Kubernetes request, and then it's also going to show the URI of the object that you are calling. So let's go ahead and hop on over to a Kubernetes cluster, and in this Kubernetes cluster, we can see here that I have a series of namespaces. Namespaces themselves are actually also defined as objects in the Kubernetes API. And in my current state right here, all of my namespaces are reflecting certain applications that I've deployed onto my cluster. Things like the Nginx ingress, Longhorn for persistent storage, MetalLB for my outside address setups. And so in my case, I've got a per application namespacing solution. But let's say I wanted to onboard a couple of new teams. So in order to ensure that these new teams can use my cluster, I'm going to give them their own namespace. And we'll call that Team A right here. So now Team A has their own namespace in my cluster. And what this is going to allow me to do is, let's say I'm in control of my default namespace, and I decide to create a deployment called my dep. So let's go ahead, create that, and we'll go ahead and create that without any kind of namespacing here. So we can see here that now I have a deployment here. And if I were to get that deployment, so if I do kubectl get deployment, and I'll do v6, and we'll also look for my dep, like so. We can see here that my kubectl request was sent over to find this specific URI, and we can see that the namespace, the default namespace in my case, has been attached to this object's URI. Now, because my URI must be unique within the namespace and really throughout the cluster, if I try to create another deployment named my dep, I'm going to get a failed to create because it already exists. Now, let's say team A doesn't quite know exactly what I'm doing because I'm a completely different team, and they decide to create their own their own deployment called MyDep. So the way that they can get around the fact that my deployment already exists is by creating their deployment using the same command or maybe the same YAML, but we'll scope it into their namespace. And now we have a team A namespace that has a deployment called MyDep. And so if I were to get that deployment, MyDep, and I'll do that in the team A namespace, we can see here that they have the deployment called MyDep, but because their deployment is in a different URI, they are going to be unique in my Kubernetes cluster. And so this is how namespaces help ensure that multiple consumers of the same Kubernetes cluster can use it without potentially conflicting with others. And that's all thanks to namespaces. If you go to rxm.com and go under training and click on the custom course builder, you'll be given the opportunity to actually assemble your own class based off of the modules that you wanted to learn about. So in our case here, we'll want to learn about namespaces, so we'll drag that into our custom course. And so with that, you can learn with us on namespaces and other topics, not just Kubernetes, but also a variety of other topics. And that's been our short take of the concept of the Kubernetes namespace.